Hello, my name is Brandon Carr, and today I'm going to be going over what chemical equilibrium is, who discovered it, and what does it mean, and why it matters. Chemical equilibrium is the state in which both reactants and products are present in concentrations which have no further tendency to change with time, so that there is no observable change in the properties of the system. What this means is that during a reaction, neither side of the reaction, either the product side or the reactant side, is moving forward. The forward velocity and the backward velocity are the same. It's not actually moving forward, and it's not actually going backwards. It's equilibrium, at an equilibrium state. So nothing's really changing with it. This is the formula, or a formula, that can be associated with the equilibrium formula. I go KASS is the rate A plus B associate and turn into AB. And just as easily as A plus B turns into AB, AB can dissociate and turn into A plus B. Next is the law of mass action. Chemical equilibrium was a concept that was developed after this law was stated, and the ones who stated it were Cato Goldberg and Peter Wage in 1867, both Norwegian scientists. Although they had a really good idea of what would later turn into the chemical equilibrium equation, they didn't quite have it for every situation. Like, an example would be for gases. Later on, a scientist by August Horstmann discovered the correct formula for that. What is it? The law of mass action is a formula to describe how the rates of reactions between the forward and backward moving velocities were in an equilibrium state. It showed how the forward velocity and the backward velocity would be the same during a reaction, so nothing was actually changing in the reaction, but it was still producing and products were still turning into reactants. So it was like you were on a treadmill. The treadmill is running forward and you're going forward with it, but you're not actually going anywhere. If that gives a better idea for people. Next is Le Chatelier's principle. This principle states that if a constraint is applied to a system in equilibrium, the equilibrium will shift so it can tend to counteract the effect of the constraint. Some things to consider would be pressure, temperature, concentration of a reactant, all differing during a reaction to change the equilibrium. It'll either shift to the left or to the right. Now, let's consider this base formula for our next examples. We're going to increase or decrease one of the sides, the reactants or the product, and we're going to see how that shifts the equilibrium of the formula. So what do you think is going to happen when we increase the concentration of A? The equilibrium is of course going to change to counteract the imbalance, because objects in equilibrium want to stay in equilibrium. So it's going to decrease the concentration of A that's reacting with B, turning it into C and D. So the equilibrium is going to move to the right. It's going to have forward velocity. Here's a better example to give you an idea of what's going to happen. Since it's going to be shifting more to the right, the formula is going to produce more C and D to create more A and increase the production of it to bring balance back to the equilibrium. Next is we're going to reverse it. What do you think would happen if we decreased the concentration of A instead of increased it? So, obviously, C and D is going to have to replace the A that was decreased, so the formula is going to be shifting to the left. They're going to be producing more of themselves, or producing more of them to create more A. Now you're probably wondering why any of this chemical equilibrium really matters to you, but here's a slide that's going to give you a couple reasons why. One of the reasons is many of the things we use today are created using this method. Chemicals, metals, foods produced with this formula. Many other things that go on have to use chemical equilibrium to function. If not, then it'd be very inefficient. Very inefficient. So to recap, what is it? Chemical equilibrium is a chemical formula that is neither moving forward or backwards. The reactants and the product are at equilibrium. Who discovered it? Cato Goldberg and Peter Waag. They're two Norwegian scientists. What does it mean? Well, it means that a formula is going to stay at equilibrium, and when the equilibrium is disturbed, it's going to shift either to the right or to the left to compensate for it and bring it back at rest. And why it matters is because it's used a lot today. It's a founding point of chemistry. You need chemical equilibrium to do different reactions. Thank you very much. My name is Brandon Corrigan, and have a wonderful day.